Modern agriculture has brought fertilizers containing phosphorus, along with other inputs, to grow crops to feed an increasing world population. And all the while, we're depleting our high-quality phosphorus sources, upon which we've built our food production systems, and arguably, our societies.
The Even Loads problem pollutant is phosphorus. 28% of it comes from agriculture and land use, but 65% of the phosphorus comes from sewage treatment plants.
Too much phosphorus creates one of the most extensive, intractable water quality problems on the planet. When trace amounts of phosphorus unintentionally run off the land and enter a water body, algae growth can become a major problem. Phosphorus in water can upend entire ecosystems, destroy fisheries, and even create vast dead zones. It takes a lot of energy and money to remove these contaminants from the phosphate rock before it can be safely used. So, what can we do about it?
Assalamualaikum warahmatullahi wabarakatuh. Good day and hello. How are you? I hope all of you are as fit as a fiddle. We are Group KA19 for final year Project 1. Our research is about domestic wastewater and also waste chicken eggshells. The title of our project is Phosphorus Removal from Water using Calcined Waste Chicken Eggshells, Kinetic and Isotherm Studies. Our group formed PASIS, which is the abbreviation of Phosphorus Adsorption using Calcined Chicken Eggshells. My name is Airil Azman bin Kamarul Zaman and I act as the group leader. Ahmad Saiful Nizam bin Asmizam and Deniel Najmuddin bin Norhaizat are another two members of our group. Our research is conducted under the main supervision of Dr. Noorul Hudai Binti Abdullah through peaks and valleys. Before starting our presentation, we would like to present the contents that we will be touching on for today. The content consists of introduction, problem statement, objectives, material and methods, expected result, commercialization potential, social benefit, conclusion, copyright, acknowledgement, and last but not least, our references.
Thank you, Azman. I am Deniel. We explain introduction. In light of the observation we have done, we have found that the phosphorus element that is the source of pollution is mostly from two sectors, namely the agriculture sector and the industrial sector. This is seen as the main cause of eutrophication, which causes biocreation to occur in the environment. Therefore, we propose a solution which is to use eggshells as a solution to this problem, as we found that it has the potential to remove phosphorus from wastewater, thus reducing the risk of nutrient contamination effect. In addition, eggshells are also seen to have great potential to carry out their function as an absorbing agent and are easily available as they are daily waste of Malaysia.
Thank you, Daniel. The problem statement of our research is domestic wastewater contains phosphorus, which is a toxic nutrient. Excess phosphorus content in wastewater will lead to nutrient pollution, which then leads to eutrophication that prohibits the entry of sunlight into water through algal bloom. This results in the death of aquatic lives due to the hypoxic condition of water resources. Adverse effects come to human when disease spread across community when they consume these dead aquatic lives due to bioaccumulation.
Thank you, Azman. I am Saiful. Let me explain the aim of this research. The objective of this research is to investigate the ability to remove phosphorus from different initial concentration of solution through different mass of adsorbents. This study also focusing on to create the counter prediction for phosphorus removal efficiency and required mass of adsorbent with different initial concentration. Last but not least, the objective of this study is to analyze the batch experiment with application of different mass of adsorbent in removing phosphorus in municipal wastewater with kinetic and isotherm models.
The methodology of our research were divided into 6 main parts, which were the preparation of adsorbent, preparation of aqueous solution and sampling, the performance of batch experiment, analytical methods, physical-chemical characteristics of adsorbent, and adsorption kinetics and isotherm studies. The preparation of adsorbent was started with washing the adsorbent with chicken eggshells with tap water and rinsed with deionized water. The adsorbent was then dried under sunshine and dried in the oven for 2 days. It followed with the crushing of the adsorbent until approximately 1.18 mm to 2.36 mm size fraction was obtained. Sieving was then done to obtain the size fraction stated. The adsorbent was then calcined at 900 degrees Celsius for 2 hours and lastly weighed and packed in 5 different masses of 2, 4, 6, 8 and 10 grams, with each mass has 10 packs. For the preparation of aqueous solution and sampling, the aqueous solution with concentration of 5, 10, 15, 20 and 25 ppm of phosphate were made. The aqueous solution with concentration of 100 ppm of phosphate was first made by mixing 0.1433 grams of potassium dihydrogen phosphate with 1 liter of deionized water. The dilution process is from 100 ppm to 25, 20, 15, 10 and 5 ppm. The sampling of wastewater will be collected at the drainage in front of IIUM Residential College, Pago. Batch experiments were divided into Batch Experiment 1 and Batch Experiment 2. For Batch Experiment 1, the aqueous solutions made were used. For each concentration of 5, 10, 15, 20 and 25 milligrams per liter, adsorbents with masses of 2, 4, 6, 8 and 10 grams will be added into the synthetic wastewater, with the volume of each concentration was 100 milliliters in 25 separated conical flasks. The mixture was then shaken at 170 revolutions per minute for about 90 minutes on the orbital shaker. The mixture was then filtered in separated beakers and further filtrated using filtration set. The concentration of each sample after adsorption was checked by conducting phosphorus procedure using the device DR6000 spectrophotometer. Batch Experiment 2 will be the same as Batch Experiment 1, but we will use the domestic wastewater collected at the sampling location. Analytical methods were done to obtain results and data using specific devices. COXAM EM30AX plus SEM was used to analyze group elements that is present in the adsorbent through EDXRF and SEM tests before adsorption process. Second generation Bruker D2 phaser benchtop XRD was used to analyze chemical elements present in the adsorbent before and after adsorption process. Perkin-Elmer 2 spectrum FTIR spectrometer was used to display the infrared spectrum of adsorption process before and after adsorption. HRDR6000 UV-VIS was used to check and measure the initial and the final concentration of solution after adsorption. We performed the adsorption kinetics and isotherm studies to analyze the adsorption process. The adsorption kinetics was used to study the rate of adsorption using pseudo first order PFO and pseudo second order PSO kinetic models. The adsorption isotherm study was performed to obtain the maximum adsorption capacity and the concentration of adsorbate at equilibrium using Langmuir model and Freundlich model. We expect to remove phosphorus from synthetic wastewater and domestic wastewater with different masses of adsorbent and compare the results between the both. We expect to achieve the removal efficiency higher than 97%. Hypothetically, the larger the mass of adsorbent, the higher the removal efficiency due to the increase of surface area for sorption process as the mass increases. We hope our findings will benefit the society and wastewater treatment industry by offering an alternative option to counter nutrient pollution and eutrophication in Malaysia. This research hopes to provide an alternative to treat nutrient in wastewater treatment system provided with contour analysis between the required mass of adsorbent and removal efficiency based on initial concentration. At the end of this research, the researchers should fulfill all the objectives of this research and obtain the expected findings as stated.
The target for the marketing of our product is made up of organization or department involving water treatments such as the water treatment industry in Malaysia. In addition, we are targeting branch of the United Nations Department so that community that do not have access to clean water sources can enjoy the benefit of our research as a result of scientific and technological developments. Finally, we will also commercialize and promote our product to the Department of Environment (DOE) at the Higher Education Institute (IPT) so that our product can be used as a sample study for future developments. Our product also be socially beneficial as our products will be able to remove phosphorus elements at a higher level than the existing technology by using only eggshell residues. This results in the fact that the operating cost water treatment will be reduced as there is no need to go through a complicated phosphorus removal system. In addition, our absorbent product made from eggshell baked by a Malaysian will be able to preserve the environment in Malaysia in general. So, the initial conclusion we can make for our product is increasing the mass of the observatory, increasing the efficiency of the removal of phosphorus from water treatment waste.
This study will be registered for copyright by MyEPO. This research was supported by Ministry of Higher Education through Fundamental Research Grant Scheme, and we would also like to thank the Neo Environment Technology, Center for Diploma Studies, Research Management Center, University Tun Hussein of Malaysia for its supports.
That is all from us. We hope you enjoyed the presentation and gained some knowledge that can be used in the future. Thank you and goodbye.